Hi, let's take a look at how to find a standard deviation from a frequency distribution. A lot faster to use StatCrunch than to do this by hand. So first thing you're going to do is open this in StatCrunch. I'm going to copy this right over to StatCrunch for us, which is really nice. The only thing is you're going to find that there are parentheses around the data and StatCrunch can't read that. So we're going to go through and remove those so that it shows us the interval. Now, if you're doing this by hand, you can follow the file that's under your document sharing in your course or, the formula in your textbook. But if you're doing this on StatCrunch, it's already got a built-in formula to let you work with this. So we're going to go double check here, make sure we didn't miss anything. Looks good. We're going to click on Summary Stats. And, we're very familiar with using columns and doing the mean and standard deviation, your fine number summary, and so forth. We look down here, there's grouped data. So we're going to take a look here and say, okay, well, where are our bins or our categories? Well, they're in the column we call interval, and our frequency, of course, is in the other one. And let's say we just want the mean and the standard deviation, so we're going to click those two and highlight those for our little printout. So here the average for this frequency distribution is 45.85, which kind of makes sense because you notice that a lot of our data is in the 40 range, and our standard deviation is 10.22. So we're going to move back to our homework here for a minute. And this particular one just asks us to find the standard deviation. So it says 10.2. Now, the next question says, consider the difference of 20% between two values to be significant. How does this computed value compare with the standard deviation given of 9? So what it's asking us is there a 20% difference between the 10.2 and the 9? So if you subtract those, you get 10.2 minus 9 is 1.2, and you divide by the original amount, which is 9. So that only gives us about 11%. So we're looking at the computed value to be not statistically significant from the given value. Hope that helps.